back in chapter 17, we talked about interference and the wave nature of sound. We talked about diffraction, we talked about beats, we talked about interference. This chapter is very similar. We're going to talk about the interference and wave nature of light and other forms of electromagnetic radiation. So first, the principle of linear superposition. 27-1. For two wave sources vibrating in phase, state the path length differences leading to constructive and destructive interference. The path length difference, so if we have a source here and a source here, and we're interested, so this is source 1, this is source 2, and we're interested in the interference at this point P, then what matters is, actually by convention, usually we have the longer path being 2 and the shorter path being 1. So let me call that S2 and S1. Then this distance L2 is the distance between source 2 and point P. L1 is the distance between source 1 and point P. And the difference between these, the path length difference, is m times lambda, where m is an integer for constructive interference. And L2 minus L1 is m plus a half, an integer plus a half, times the wavelength for destructive interference. Here are the two distances, here's the wavelength. And you might be saying, hang on here, I think I've seen this before. And in fact, this is absolutely identical to concept 17-4. And you say, well, why do we have it as a separately identified concept? And the reason is just to make sure that we've got it, again, in studying light interference versus sound interference that we talked about in chapter 17. So, just like chapter 17, we've got two different sources, 1 and 2, and we've got, in this case, electromagnetic rays, or radiation, or electromagnetic waves. So you can think about this as electric fields, and they combine at some point P. If the path length difference is, as in this case, an integer multiple of the wavelength, 3 1/4 lambda minus 2 1/4 lambda, path length difference is L2 minus L1 is lambda. So that's an integer multiple of lambda, where that integer, in this case, is 1. Whatever is multiplying lambda is 1. Then we get constructive interference, and the two waves, the peaks and the valleys, come at the same time. We get constructive interference. If instead we have a case where the path length difference is half a wavelength, so 3 1/4 minus 2 3/4 is just half a wavelength. So that satisfies the m plus 1/2 lambda criterion, with m, in this case, being 0. So if you plug in 0 into here, 0 plus a half is a half, half a wavelength is half a wavelength. Bingo. And we get peaks coinciding with valleys and destructive interference, and we get cancellation of the, in the old case, sound, in this case, light. So for constructive interference, when we get this kind of situation, we get bright light. We're going to call those bright fringes. And this is also called a maximum. So we'll use a lot of words to describe the same thing, but basically, ultimately, it boils down to constructive interference. Here we get, we call these dark fringes. So with sound, it's soft sound, loud versus soft, and now it's bright versus dark in terms of light. All right, an example. In a shallow pool of water, two needle-like dippers They move up and down at the same constant frequency. So at these 2 points, something coming up in both places, down, et cetera, et cetera. Water waves move outward from each source as shown. The wave crests, represented by solid lines, have an amplitude of 0.4 centimeters. What does that mean? It means that relative to the undisturbed water, the nice flat mirror water, the waves go up by 0.4 centimeters, and half a cycle later they go down below the surface by 0.4 centimeters. So the distance from the smooth case to the maximum is 0.4. So what is the displacement of the water relative to the undisturbed water level at the point labeled P? Well, as you can see at point P, we're at we've got a crest from the wave on the left, and we've also got a crest from the wave on the right. We've got 0.4 centimeters from the left, 0.4 from the right. They add together, and we should get 0.8 centimeters. And the reason it's 0.8, it's plus, is because these are crests, these dark lines are crests, rather than troughs, in which case it would have been minus 0.8.